Okay, if you thought yesterday's lesson was fun, you are going to have fun with this one. I need you to take notes. I need you to take a picture of your notes and send them to Miss Doolin or Miss Copy. I need you to also do your very best and ask questions if you need to, but all the things will be given to you. All the keys will be open after you do your homework, okay? So take notes. Remember, you can pause the video anytime you need to. We are going to write some new definitions. First definition is called the supplement theorem. A supplement theorem says that if two angles form a linear pair, remember linear pair makes a line, then they are supplement. Or I should say they are supplementary, angles. If two angles form a linear pair, then they are supplementary angles. We knew that. If they make a line, they make 180, okay? So what does this mean? You'll be given some problems like this where they give you an angle. They tell you this is 1, this is 2. Oh, it's making a line. So if measure of angle 1 is x plus 10, and the measure of angle 2 is 3x plus 18, then how could I solve for x? Well, I could put them together, x plus 10 plus the 3x plus 18, angle 1 and angle 2, and I can set it equal to 180. They're supplementary to each other. And then I do want you to solve for this. So this would be 4x plus 28 equals 180. And then 4x equals 152. And divide by 4, you get x to be 38. Now that's what x is. But if you were to find the angle measure, you'd have to put 38 back in for x. 38 plus 10 makes 48. And then 38 times 3, that's what that is, 38 times 3, and add 18 would be 132. And just double check, aren't those supplementary to each other? 132 and 48? Bingo. Then there's the complement theorem. Don't you think it's going to kind of be the same, right? Two angles are complementary, okay? So the definition says that if the non-common sides of two adjacent angles form a right angle, ignore that little, sometimes I put A and right together, form a right angle, then the angles are complementary angles. Okay, so here I've given you another picture. I see that right angle right there. I know by the supplement theorem that 3 and this right angle are forming a pair, so that means this must be a right angle. And then this 3 is forming a right angle with both of these. So I know that these two must be making 90 degrees together. So if the measure of angle 4 is 2x minus 5, and the measure of angle 5 is 4x minus 13, those two together, if I add them together, must make 90 degrees. And then it's just some simple algebra. 6x minus 18 equals 90. Add 18 over, you would get 108. And then 108 divided by 6 is 18. And then again, that's just what x equals. Plug it back in to find the measure of each angle. So if I plug 18 in to this angle right here, 2 times 18 minus 5. So 36 minus 5 is 31. So the measure of angle 4 is 31 degrees. and then plug 18 right there. 4 times 18 minus 13. 4 times 18, 72 minus 13 is 59. And if those two add up to 90, which they do, pretty good. You'll have questions just like this in the beginning of the worksheets that I'm going to give you for homework tonight. Okay? Now, just like anything, we got some properties about these angles. Very similar to segment addition property yesterday. So the properties of angle congruence. We have the reflexive property, the symmetric property, and transitive property again, but we're going to put this with angle congruence. So what does that mean? So let's say I have angle 1 and I want to write that it's reflexive to itself. I would just say, okay, angle 1 is congruent to itself, angle 1, or angle 2 is congruent to angle 2, or angle ABC is congruent to angle ABC. It's congruent to itself. Again, we didn't use that yesterday. Not sure if we're going to use it again today, but I know in the future it will come up. So reflexive. Symmetric. Did you remember symmetric about yesterday with segments? If AB equals B, if AB equals CD, then CD equals AB. It's the same with angles. If angle 1 is congruent to angle 2, then angle 2 must be congruent to angle 1. Easy peasy. Transitive, remember that train property from yesterday? If this equals this and this equals this, then that equals that. Okay, same thing. So if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 must be congruent to angle 3. If this equals this and this equals this, then the two ends equal to each other, okay? Other quick theorem, congruence theorems. You're going to hear these congruence theorems, and they say the following, that angles supplementary to the same angle or congruent angles are congruent. And what that pretty much means is if I'm telling you that 1 and 2 are, and then we'll do it like this, and 3, okay? Angles that are supplementary to the same angle. So 1 is supplementary to 2, and 2 is supplementary to 3. Or if they're congruent to 2 angles, they are congruent. Wouldn't that make sense? Wouldn't 1 and 3 be the same measure? I mean, if this was 50 degrees and this was 130, then, and this one is also supplementary to that one, that must also be 130. They must be congruent to each other. That's all that's saying. And there's another corollary, similar theorem that says that angles complementary to the same angle. Angles complementary to the same angle or congruent angles are congruent. And it follows the same pattern. All right, one of my favorite theorems is vertical angle theorem. I love vertical angles. They're just so easy to look for. They just are opposite each other, 1 and 2. And the vertical angle theorem says this, that if two angles are vertical, then they're congruent. Makes sense. Vertical angles are congruent. So if I told you that, when I said 6 and 7, look at my notes there. I don't have a 6 or a 7. So let's just change that real quick. Here's a 7. Here's a 6. All right. If the measure of angle 6 is 7x minus 24, and the measure of angle 7 is 5x plus 14, those two are vertical, then those two are equal. So 5x plus 14 equals 7x minus 24. And now do some lovely math. Subtract 5x and add 24. we get, and then we divide by, obviously, 2, and you get 19. And then you got to plug it back in. Don't forget, that's just what x is. So take x, plug it back into your angle. So let's find out what the measure of angle 6 is. So it'd be 7 times 19 minus 24. I need my calculator for that. 7 times 19 minus 24 is 109. Now, it definitely does not look like a 109, but, never judge it by its angle, by the way it looks. Measure of angle 7, let's just double check that. That would be 5 times 19 plus 14. And let's just double check that makes 109 because we know the vertical angles. And it does. 95 plus 14 is 109. Okay. Now, let's try a proof. No, that sounds very vicious. No, they're not bad at all. Again, might take a moment to pause this right now and write this all down, and then I'm going to talk you through it. That way it's a little bit easier for you. Okay, so we're given that DB, ray DB, bisects angle ADC. Let's talk about bisects again. Bisect, sect is a suffix that means to cut. Bi means two, so you're cutting into two equal parts. You should have known that from bisector. So I know that if this guy right here is bisecting ADC, you should know something about 1 and 2. So our job, though, is to prove that angle 2 and angle 3 are congruent. That's very interesting. We'll find out about that. All right, so they've given us the statements. We're going to go through the reasons. Number 1 looks like a given because it is. It's given. Okay. Number 2. Why is angle 1 congruent to angle 2? Well, remember yesterday with midpoint? Remember we had definition of a midpoint. Very similar when they say, oh, DB bisects. That's definition of an angle bisector. A bisector is going to make these two equal to each other. This is definition of an angle bisector. It's bisecting angle. It's making the two of them congruent. All right, now let's see what we have here. Number 3, angle 1 and angle 3 are vertical angles. Yeah, they are vertical angles. Why? Give me a reason. That's the definition of a vertical angle. They're opposite each other like that, okay? Definition of vertical angles. All right, now, if I told you they're vertical angles, why am I allowed to tell you that they're congruent to each other, which is number 3? Angle 3 is congruent to angle 1. Why am I allowed to say that? We'll go back. If two angles are vertical, which we just said they were vertical, two angles are vertical, then they're congruent. So that's what you can write. You can actually write that whole long thing, or you can say the vertical angle theorem, or I just say vertical angles are congruent. All vertical angles are congruent. All right, now it looks like from 4, 5, and 6, I'm going angle 3 to angle 1, angle 3 to angle 2, angle 2 to angle 3. I have a feeling we're going to use those reflexive symmetric transitive properties. So let's see what we're doing now, okay? And don't forget about up here, angle 1 is congruent to angle 2. So going back all the way up here, if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 1, okay, then why am I allowed to say that angle 3 is congruent to angle 2? You could say, yes, I've seen it before. It looks like you're just, substituting, and I'm totally fine with that. I would also use, though, I would say that it might be the transitive property a little bit better. 1 goes to 2 and 3 goes to 1, then 2 must go to 3. That would be more of a train. But again, if you wrote substitution, I wouldn't take off for that. All right, and now why am I allowed to go from 5 to 6? Why am I allowed to say that angle 3 is congruent to angle 2? And now look what happened. Switch, flip-flop, mirror. That's symmetry. symmetric property of angles. So not too hard, not too hard. Let's talk about an angle addition postulate, very similar to the segment addition postulate. If this little piece and this little piece make a whole piece, same with an angle. This little piece and this little piece make the whole angle. So I don't want to say if, it's just going to use measures. If I'm going to say the measure of angle ABD, so this guy, and I add it to the measure of angle DBC, then I've just made up the entire angle, the measure of angle ABC. Okay? And we're going to use that. We're going to use that for sure. All right, moving on. One last theorem, and then we'll do one more proof, and we'll be done here. Right angle theorem. The right angle theorem, very easy. All right angles are congruent. That makes sense. If you're in a right angle and I'm a right angle, we have the same measure. We are congruent. We're 90 degrees, okay? One more little side note to put underneath here. Another, they call it a corollary, something that we can pull from this. But perpendicular lines, this is the symbol for perpendicular. Perpendicular lines intersect to form 4 right angles. If you have 2 perpendicular lines, they're going to intersect to form right angles. We kind of saw that from my first example when I did the complementary ones. All right, now our last proof, because we love proofs. Proofs are easy. Here's your skeleton proof. Looks like most of my statements are given, and I got to supply the reasons, except for one of them. But it's going to be easy. We got this, okay? Remember, there's always a given. If it's in angles, there's probably going to be angle addition postulate. There might be some definition of a vertical angle, definition of a right angle. You look for those things. All right, so angle 1 and angle 2 are complementary. Prove that angle ABC is right. Well, it looks right, I know, but we got to logically argue it. So number 1 is our given. We know this, okay? All right, why am I allowed to say that angle 1 and angle 2 are equal to 90 degrees based on what was above? Complementary. Definition of complementary angles. If they're complementary, then they add to 90. If they're complementary, then they add to 90. All right, now, they didn't give us a 3, but they did tell us they want us to put an angle addition. We know angle addition is just like segment addition. This guy and this guy make the whole guy. So I'm going to say the measure of angle 1 plus the measure of angle 2 make the whole guy measure of angle ABC. Angle addition postulate. All right, now to statement 4. Why am I allowed to say that angle ABC is equal to 90 based off of what's above it? Aren't those the same thing? And aren't I allowed to then say that these two are equal to each other? So I'm just substituting. I'm substitution. A substitution property there. I'm just putting a 90 right there. All right. Measure of angle ABC equals 90. Why am I allowed to say that ABC is a right angle? Hint, hint, hint. Definition of complementary? Why am I allowed to say that? Definition of a right angle. Easy. All right, that's it. You got a study guide tonight. And if you're in the honors, you got some skills. That's what I'd like you to work on. That's it. Bye-bye.